Let's talk about finding the distance between two given points. The first thing to really do is just think about, it could be these 2 points or any other points, but draw the 2 points carefully and draw the point here 6, 3 as well. So 6, 3 has been chosen because it's taking one of the point's x coordinates and the other point's y coordinate. And you can find the distance from point 1 to A and point 2 to A easily because they're horizontal or vertical distances. So you've got a situation that looks like this between the 2 points, and there in red is that point A. You see that what you're forming here is a right triangle. And so these the vertical distance here, 2, and this horizontal distance of 7, those are easy to compute, right? It's always the bigger x value minus smaller x value, or bigger y value minus smaller y value. And it's always a minus. Don't let the fact that one of the coordinates here, this x coordinate, -1, don't let that throw you off. Don't start putting a plus sign. Instead, it's not 6 plus -1, it's 6 minus -1. Okay, the point being then that the piece we're looking for is the hypotenuse of a right triangle, so we can apply the Pythagorean theorem. Having applied the Pythagorean theorem, we can square root both sides, and you'll see the distance between point 1 and point 2. In general, is a formula that's given like this: square root of, in parentheses, x2 minus x1 quantity squared, plus, and then in parentheses, y2 minus y1 quantity squared. Right? This is what you have seen and probably recognized in the past as being the distance formula, but I think it's important to just see really where it comes from, to really just think about this plus sign right there is coming from the plus sign in the Pythagorean theorem, and the minus sign here and the minus sign there is because, hey, that's what you do when you're computing a purely vertical or purely horizontal distance, and those are the things we did to be able to figure out this slanted distance here. Now, the key thing that occurred here, I've already really said it, is that 2 points that share the same y coordinate, so you have x1 comma y and x2 comma y, emphasis on the same y. All you have to do is find that height, this vertical distance between the two. Here in this case, they have the same height, so you're just finding this horizontal distance, x2 minus x1, bigger x value minus smaller x value. That's all that's going on. And so you'll see here in even this little example, I've got the point with x coordinate 4 and a point with x coordinate 3. The distance between these two is 1. And you'll see, the one I really wanted to illustrate, looks like this. When, you have 4 minus -1 is equal to 5. 4 minus -2 equals to 6. Sometimes the temptation is for people to say 4 plus -2. They won't get 6, right? You'd get, let's say 4 plus -2. You'll get 2 for that. And this distance is not at all 2. Look at it, keeps growing. Okay. The thing is, instead of just the xy plane, we're now going to deal with xyz space. So most of what we end up doing in Calc 3 ends up being three-dimensional. Typically, though not always, z is the height, and we'll try to think of it that way. Now, which of these is correct? In some sense, either of these will work, but we do have a convention we'll use, and it's not this drawing on the left, it is this one over here where you've got the x-axis kind of pointing to the lower left, and then the y-axis pointing to the lower right, and the z-axis pointing up. Okay, so on page 6 of the slides, it is the drawing that's on the right. Now, how do we know? There's a thing called the right-hand rule that determines this. How does this right-hand rule work? I've heard it described a lot of ways. People have shown kind of gestures with their right hand, which I have found rather confusing. So I'd like to describe it this way. If you draw the x, y, and z axes, and if you draw them correctly, the following should happen. Say that you have a bird located way up, where x is 0, y is 0, but way up? Well, the height is the z coordinate, so that's why there's a 100 here. From where a bird might be located flying above, looking down at the xy plane, the x and y axis should look normal for two-dimensional graphing. So imagine kind of up here is a bird, and then that bird might have to rotate which direction they're looking down at the floor over here, which is formed by the span of the x and y axes. But if the bird is facing, I guess, so the bird is located like where the little z is located on the axis, but the direction the bird would look would be towards where this y is here. So the bird is located up here, but looking down at the ground towards the y. Right? It's like the bird's body is rotated so that the head of the bird is pointing the same direction as the arrow points on the y-axis. Then when the bird looks down, the bird would see like a normal xy plane where that x-axis would look horizontal and the y-axis would look vertical. If these x and y were swapped, then it just wouldn't look right to the bird. We're of course assuming the bird knows what an xy coordinate plane looks like. You get what I mean? Okay, and then just for some names, back in the xy plane, this first pink colored region is called the first quadrant. And then in space, the portion where x, y, and z are all positive is called the first octant. Octant because there's 8 of those things. So unlike quadrants where we name them 1, 2, 3, 4, we only actually name the first octant. The other 7 octants just don't get names because it's just really hard to determine what order we should put them in, and we never really have to, refer to them by name anyway. Okay, so on your own, you really ought to try this. Draw a set of axes. Please draw them correctly, x, y, z axis, and then draw the point 0, 0, 0, and 3, 0, 0, and so on. Please try those, and then describe what the xy plane is, the xz plane is, and the yz plane.